As we go on to topic 4 of chapter 2, we're going to be dealing with linear functions. And these are some of the subtopics we'll address. Graphing linear functions, standard form, ax plus by equals c, slope, average rate of change, and then linear models. Well, when we look at one of the basic linear functions that I actually mentioned in the previous lesson, we can often substitute the f of x, we said, with a y. Y equals, I'm going to change the a to the m, and there's the typical slope, which is what m is, and then b is your y-intercept. Here they're just putting an a there instead of the m. But we will be working with this to show you how to graph and how all of this links into each other. Your instructor may give a little twist on this, but this is the way I like to do this. So what they want us to do here is to find the domain and the range. And again, we did some of this before of this particular function. So we're going to change the function to y. We're going to go 2x, that's a negative 2x, plus 6. Now, we can put some various points there, but I think one of the easiest ways to graph is the technique that we used in Math 1103, where b here, this b right there, is the y-intercept. So we go 1, 2, 3, 4, 5, 6. That's where this line will cross the y-axis. So we put a dot right there. Now the slope, which is what's the numerical coefficient of x, is a negative 2 over 1. So since it's negative, I'm going to go over 1, and we'll see shortly more detail on this. And then I'm going to go up 2, and then I draw my line. Now there's an infinite number of points along this line. And we're asked, what is the domain? Well, the domain would be, again, for x values from negative infinity to positive infinity. And the range coming up here from, these are y units, negative infinity to positive infinity. And that's what they're showing here. All right, let's go on. Now, another thing, too, that they're showing, and I think we've mentioned this before as well, that where this line crosses the y-axis, this is our y-intercept, and interestingly, it crosses the x-axis right here, and this is our x-intercept. Now, there's a formal way to write this, and a little tool I offer to my students is what I call an X and Y intercept t-chart, where you put X as a 0 here, and then next slot down you put the Y. So recall our equation was Y equals a negative 2x plus 6. So that if our x value is 0, negative 2 times 0 is 0, our y-intercept is 6. And another way to write that, or the standard way, is 0, comma b. That would be your y-intercept. Now, for our x-intercept, we have to have y is 0 over here. So I'm going to transpose that 6 to the other side, because that's a 0 now. Transpose the 6, and I get a negative 2x. I'm going to divide both sides by 2. negative 2. And I get this as a 3. So x equals 3 here, and that's what they have, 0, 3. And we often, the formal way to write that is a, 0. So anytime you have these coordinates, a 0 for the x, whatever value you have for the b, that is your y-intercept. And then if you have an x value and your y-coordinate is 0, then this is your x-intercept. And that's what they're describing here. Let's go on. Now in our 1103 course, we talked about graphing horizontal lines. Again, this could be a y here, equals a negative 3. Well, this is a typical graph that we have a formal way to write it, y equals b, where b, recall, is your y-intercept. So for something like this, it's just a horizontal line, and when you put it in MATLAB, you put a dot at negative 3, and then anywhere else to make it. And if you did it on your calculator, it would look like this. Now, what is the domain of this? Well, the domain is from negative infinity to positive infinity. But the range now is just this value of negative 3. Okay. Now, they're not putting it in a bracket. I don't know if that's just the way they're illustrating that, but it should be in brackets. Now, the graph of a vertical line, the formal way of writing it is x equals a. So in this case, we have x equals negative 3. Well, again, this will be the equation of a vertical line going through your x-intercept at negative 3, and then just making any other point in MATLAB, and that's your vertical line. And the range of this, or the domain first, will just be a negative 3. And your range, as you can see, will go from negative infinity to positive infinity. And they're using braces for some reason. Not sure about that. Okay, we're being introduced here to standard form. Again, this is another typical equation that we use and see a lot in graphing, where there's your x value, a is the constant, there's your y value, b is the constant, and it equals some constant. Okay, standard form. So, as we look at this, all of these, they're saying, are modifications of this, but I would say it has all the elements, but it's not written in standard form. The only one that's written in standard form is this one here. Now, notice if you have this up here, and you multiply everything by 2, it becomes this. So all of these would be equivalent, but the only one really in standard form is this one and this one, but the others are modifications of it. Let's go on. Now here we see something in standard form, and they want us to find the domain and range. But here, our value of our constant happens to be 0. So, if we were to make, in this case, since we want to find and graph it, an x and y intercept, you'll notice if you put a 0 there, this is 0. And if you put a 0 there, this is 0. So we don't get very far in doing our graphing, because when we see something like this and our constant is 0, the y-intercept is the origin. So how would you graph something like this? Well, for me, what I'd do is I'd write the equation 4x minus 5y equals 0. I'd bring the 5 over to make my y positive. And then I'd solve for y. And I'd get, I'd write it this way now, y equals 4/5 x. And if we put it in slope-intercept form, we said there wasn't a b there, so that's just 0. So we plotted at 0, but now we can plot the slope. And we're going to get to this very shortly, so we're just showing it to you a little ahead of time. And we'll find that slope is a ratio of y units to x units. So we're going to go over 5. 1, 2, 3, 4, 5. And go up 4. And there's our second point. So from that we can make our line. And that's what we have over here. Notice our y-intercept is 0, 0. We go over 5 and up 4. Now, are there other points? Yeah, but sometimes you get fractions, and you want to try to stay away from fractions. They're hard to graph. All right, let's go on. Now, they're tying this into a graphing calculator. If you solve for the letter y like I did, and then y sub 1 comes up, you put in 4 divided by 5, and then the x in the calculator. This is the graph that you get. Now, they are tying this in a little bit now to introduce the concept of slope. Slope is how the line, in a sense, leans, or the characteristics of the line. And here, if you had let me get a pen here. If you had a point right here, this is an ordered pair. And if you had this point, this is an ordered pair. If you were to make a little right triangle, and again you're projecting down to your x-axis here, this is your run units. These would be your x units. And then if you projected to this axis this way, these would be your rise units. So we often say m, that's the letter we use for slope, is a ratio of y units, which is rise, over x units, which is run. So we say rise over run, and that forms a ratio. Now, looking at a graph, we can actually sometimes pick it out. How many units is it going over this way? Looks like about 4 units there. And counting from here, going to the right, is positive. Now, starting here and going up, again about 4 units, that would be our run. And again, also positive. So we have 4 rise and 4 run equals the slope of 1. Now, whenever you have a whole number, like 1 or 2 or 3, remember that is over 1. This is actually 1 over 1. So if the slope is 1, then you would go over 1 unit this way, 1 unit up, or 4 units this way, 4 units up. Now they're introducing this little symbol. It's not anything to be frightened of. It's just read as delta x, which is the amount of rise, and delta y is the rise, and delta x is the run. Okay, so actually this gives rise to a formula that we're going to see here right now. And again, they say it can be done in a number of different ways. I would suggest you just learn one. And they're using the letter M equals the difference of your ordered pair, the y values, y sub 2 minus the y sub 1, divided by the x sub 2 minus the x sub 1. This is the slope formula, and that's what they're showing here. Now, we'll look at some specifics of this as we go on. And here they're just showing that it could be done a number of ways. But again, let's stick with just one way. Here they're saying you can't mix up your x sub 1s and x sub 2s. Okay. Now, we did mention some of these slopes, and you will be working out the some of this. In fact, let's just do one here so you see how it's done. We'll do letter A here. So y sub 2 is going to be a negative 3. Y sub 1, and remember it's minus whatever y sub 1 is, which is 8. And then our x sub 2 is 2. Minus is in the formula. And here's where it's a little tricky, that your x coordinate for x sub 1 is a negative 4. So here we have two negatives, which we could just make a positive there. So in our numerator we get a negative 11, and in our denominator we get 2 plus 4 is 6. So our slope is a negative 11/6. Now remember, you could put the negative in the numerator. The usual place to put it is by the division bar here, or you could have had the bottom, the denominator, be a negative, but only one, and doing that carefully. And here they'll show us the others. That'll save us a little time in writing them out. Now, when we see something like this, and it's a negative 4 minus 7, 2 minus 2, that is, your denominator becomes a 0, this type of slope, whenever the denominator ends up being 0, is undefined. And perhaps we could give you a little summary here. When we see slope that starts low and goes high, this is positive slope. When we see slope that starts high and goes down as it goes to the right, this is negative slope. When we see a line that is horizontal, like so, the slope is going to be 0. And when we see this one, which is a line in which it's a 2, this will be a vertical line, and the slope of a vertical line is undefined because our denominators end up as 0. Now for this one, our denominator is not a 0, but our numerator is a 0. So a little summary, and pause if you need to get some notes, because this is good stuff. And here they're just giving you a summary. 0 slope is the slope of a horizontal line. So if you have an equation, and they're giving you lots of stuff here, and I'm just going to summarize it for you, that's in slope-intercept form, whatever the coefficient of x is, when it's in this form, this is your slope. And whatever is in this position is your y-intercept. Now, if there isn't one, as we've mentioned, it's the origin. But we're going to use this property of this line, that whatever the numerical coefficient of x is, that's the slope, to do some graphing. But before we do that, we're going to take a look to find if we have an equation that's in standard form, how do we find the slope? This is ax plus by equals c. And we said we could easily find the slope if it's in this form. Y equals mx plus b. Well, the answer is to solve this equation that's in standard form here for the letter y. So we transpose that to the other side. It changes its sign. And then we divide everything by 3. We get y by itself. So now the negative 4/3 is the slope, and the plus 4 is the y-intercept. And again, it's very useful for graphing. Once again, we plot our y-intercept, 1, 2, 3, 4. Put a dot right there. Our slope is a negative 4/3. So we're going to go in a negative direction with our run. And then we're going to go up vertically with our rise. And remember, I'm not using graph paper. 1, 2, 3, one more, 4. And then you would, again, in your math lab would put a dot there on the y-intercept, mentally go over 3, then 1, 2, 3, 4, put your second dot there, and then your graph forms. Now, you've plotted the y-intercept here, but we don't know what the x-intercept is. We'd have to find it or do some calculation to get it. Okay. And here they are now asking us to use what we've been doing to graph this. Graph a line using a point and the slope. Okay. So the point they're giving us is a negative 1, 5. So let's just do that. Now they have it done over there too, but often you'll be doing it on your own. So negative 1 is right there. Then we're going to go up 5. 1, 2, 3, 4, 5. So the point negative 1, 5 is right there. Now from that point, we want this slope. So again, it's negative 3. So we're going to go 3 units this way. 1, 2, 3. And we're going to go 5 up. 1, 2, 3, 4, 5. And then again, you would click there, mentally go over 3 in a negative direction, go up 5, and then there's your line. Now notice we didn't use the y-intercept to graph it. We used the point they gave us, and from that point we sketched in the slope. So this is one way to do it. We go over 3, and then we go up 5. There we go. Now they went down 5 over 3. That's a perfectly good way to do it. If you went down 5 over 3 would be right there. Okay, so again, you want to develop a technique for doing this and be ambidextrous. That is, you could do it this way or you could do it this way. But remember, coming high, going down, that's negative slope. That's what they're showing us here. Negative slope. And once again, they're giving us a review. The red line starts low, goes up, positive slope. The purple line starts high, as you go to the left, goes down, negative slope. And a horizontal line is zero slope, which is green. And then the blue line is a vertical line. That, again, zero is the slope of a horizontal line. Undefined is the slope of a vertical line. So lots of good stuff here, and we reviewed it again for you. So here they're talking about average rate of change, and you can read that over if you like, but let's go on to our example, because here they're saying this word problem. I'm not going to read it all, but it looks like in 1980 you sold this many, or it cost this much, but in 2008 it costs this much. And if it's a straight line or linear increase, theoretically you can make a graph out of it. You have two sets of data points, and you can find the approximate slope. And that's what they've done here. Put your y values on top, x values on the bottom, and you find the slope, and there it is. Okay, another little thing that they're doing that we did do in our Math 1103 also is talk about the function in which we have c of x equals the cost of producing 1 unit plus fixed cost, machinery and other things. And you could model it on slope-intercept. Y equals mx plus b, where this is the slope and b would be your fixed cost. So let's go on. Now, along with fixed costs, we have revenue. So for every unit you sell, you're going to get some revenue. And this is the revenue function, that for every item you sell, which would be the x's, you're going to charge a selling price. So that's what they're saying here. Now, with this, we can develop what is called a profit function. That our profit will be the revenue that we take in minus the cost. So we had the cost function on the other page. So let's look at an example here. This is background. So equipment and things was $1,500. It costs $100 to make a particular item. And our revenue function is for every item we sell, we're going to sell it for $125. In a previous course, we said what was our break-even point. But here we want to know, where do we start to get profit? Well, there's your revenue. Now it's critical to put your cost in a parenthesis, because you're going to subtract it. Now notice what happens. This becomes negative. This becomes negative. We do our subtraction of this and that, and we then get our profit formula. So look at it this way. If it costs $100 to make every item and you sell it for $125, there's a $25 profit on every item. But you still have to overcome your overall cost of machinery. So once you get enough money generated here and you subtract 1,500 from it, you are finally going to make a profit. Okay. And they're showing this as a graph, which is above this line. This is where your profit starts to come in. Here you're selling things, but you haven't made enough money to get to this point right here is the break-even point. Okay. I think we're getting close to the end, and that is the end. And you'll be doing practice and your quiz bees to see if you've gained mastery.